Welcome to Cpp.chat, a sometimes weekly look at what's going on in the world of C++, chatting with guests from the community. We'll introduce this week's guest in a moment, but first we'll just get John to read an unimportant disclaimer. John?
Thank you. So this week's disclaimer: the terms for using, copying, modifying, and distributing Cpp.chat episodes are specified by the Cpp.chat license. The license agreement is distributed with Cpp.chat episodes in the file license. If for any reason you do not have this file in your distribution, it can be downloaded from http://cpp.chat/license.html. Some of the code and executables used by Cpp.chat have their own usage restrictions. So hello. It's great to be here, even if I had to get out of bed early to make it, because we're doing this at an insane time from the point of view of my home.
Well, it makes a change. I was up until 2 a.m. last time we did this.
That's right. So I guess, what comes around, something like that. So how are you doing, Hannah?
I'm doing great, and it's great to see you again, both of you.
Hi, Hannah.
Hello.
So I was just, I was telling you before we came on that I don't know what, if you, as the speaker at CPPCon, you probably get a lot of people telling you, oh, I saw your talk, or whatever. But I'm getting a lot of feedback about your talk. Your talk got an exceptional amount of attention. And I see this because I see all the, the feedback from a lot of people. And so, so I just want to let you know that your talk has been very well received. I haven't really looked at the view numbers or anything like that, but just the things that I've heard.
Thank you. It's really great to see to hear it.
Yeah. Well, did you feel like you got a good response?
I got a lot of response and a lot of Twitter replies and mentions, and it was crazy 3 days after talk. My tweet at Twitter was always beeping, something going on, and I was like, what's going on?
Well, someone proposed that we get a t-shirts printed that says I was there live or something like that, like it was an event.
Yeah,
I guess we should tell people about the talk. The talk was you gave a talk. I mentioned the exact name of it, but it was on being able to do regular expressions at compile time.
Mm-hmm. Sorry.
And what's that?
I have a problem hearing you. Sorry.
Yeah, I'm having a little difficulty hearing. I hope we can in the podcast so it comes out a little clearer. But yeah, I'm having difficulty hearing. This is the performance of the regular expressions, because the actual building of the staging is done at compile time instead of, correct?
I have problem hearing you, but I presume you ask about compile time regular expression, why I decided to make them in compile time, and my motivation was to outsource much work of as much possible of work to compiler, not to runtime of my program, because my program is running on servers, and I don't want to spend time on building regular expressions.
Yes, that's pretty much what I was asking. Are you hearing her fine, Phil?
You are breaking up a bit. I think you may have a problem with your signal.
Okay, maybe the electrons are tired this early in the morning. That's possible.
That's quite likely.
Yes. Some caffeine. Yes.
All right. Definitely problem.
Oh, now I think I'm hearing a little better now. So what I was going to say is this is kind of a trend of what we're trying to accomplish in C++ generally, making more and more things const expr. I know we advance this in a few in San Diego in a few areas where we can now do allocations in const expr. Is that correct?
Yeah. I think the trend is to const expr more of the things.
Yeah, Ludion is all right.
Yeah, more of the things, yes. So I think we can even now try and catch in const expert. We can't throw, but we can try and catch. Is that right?
Yeah. That's
or at least
correct.
we can have try and catch statements, right? So they compile at least. So that a function, obviously, we can't handle exceptions. Well, I should say obviously, but at this point, we can't handle exceptions at const expert time code that, if it's not at const expert time, would handle exceptions.
Yeah.
Is that the idea?
Throwing exception is compile time error now. At least as I understand it.
That's correct. Yes.
Get that. I'm sure
I think everything should be const expert. Everything known at compile time should be const expert, or optimized away. So your programs will do only what needs to be done during runtime, not nothing else, not a bit more.
Right. And in fact, this is what the D language does. They don't have a const expert keyword. Everything is just const expert if possible. It's kind of implied. But of course, we aren't that way, right? We have to label things as const expert, at least at this point. And there's certain things that we just can't label as const expert. So we're getting there, right?
Yeah.
The idea of doing the state machines at compile time is not completely unknown. That's what Expressive does, right? In the by Eric Niebler, his library, but it takes a bit of a different approach because it uses domain-specific embedded language, right?
Yeah, he's using operator overloading, and it's great solution for problem, but I found different way how to handle it, and I'm parsing pattern as a string during compile time. It can be done in C++ 20, and with some hacks in 17.
So the advantage of what you're able to do is that you're actually seeing a string of traditional regular expressions. With the operator overloads, there's cheating involved about placement of Klein stars and things like that, right? With the expressive library, you have to put the Klein star in front of something just because that's C++ syntax, right?
Yeah, you need to know special syntax and operator precedents, and know what read the documentation and try to translate your regular expression into special syntax. With my library, you can just take your regular expression with PCRE syntax. You should already know, at least partially, and then just place it in your code and use it.
Right. Of course, that assumes you have the regular expression at compile time, which usually we do.
Yeah.
The only time you wouldn't is if you actually had live searching. You were supporting live searching with regular expressions.
Yeah, and that's only cases when you're programming text editors, maybe databases, or compiler, maybe. But usually your regular expression is static.
Right. You know the format of what you're parsing. You know what you're looking for.
Yeah.
What sort of impact does that have on the runtime of the? Obviously, not the parsing of the regular expression itself, but parsing a text string with a regular expression once it's been compiled at compile time.
My library can parse subject even in compile time, but it's not much useful feature. You can decide if your subject is matching your pattern or not, and you can capture some content of it, but you know already that string during compile time. So
right, but assuming you have compiled the regular expression at compile time, and then you're matching a string at runtime, is there any impact on the performance of the runtime part of that?
Actually, I'm even quicker than PCRE library.
That's a good sign.
Only in some cases, RE2 library from Google is a little quicker or on par. And Hyperscan from Intel, which is not exactly regular expressions, are much quicker, but it's different. Dark magic, I don't understand what they're doing, but they are much quicker. But they have limited subset of problems, and then they are specialized in something else than I'm trying to achieve.
But presumably those differences are really down to a quality of implementation. So you could potentially reach at least.
And actually, Actually, my implementation is not a state machine. It's a depth search first algorithm.
Right.
So I'm trying all combination currently. I'm working on rewriting it to finite machine, but I'm not there yet.
And how many times have you rewritten your library so far?
I think it's actually 6th or 7th time already. I tried.
Is that more than the number you gave on CPP Caster a little while ago?
No, it's I tried different approaches and different techniques, and I found that function overloading is the best one for my use case.
And we could be confident that that is the best because you've tried all the others.
I don't know if all of them, but I try most of them. During CPP now, or during talk from Stephen Lafayette, I got idea to use Cpp.chat as a mechanism inside of the library, and it's working. There is a working branch with Cpp.chat instead of function overloading.
Okay. And how does that impact it?
Does that give you in there, or was it just something you tried?
I tried, and performance-wise, it's similar, so I decided to not go there.
Right. Makes sense.
Well, speaking of CPP Cast, one of the things I think you talked about there was your local user group. You've put together quite a series of guests that have come and spoken into your user group. You want to tell us a little bit about that?
Yeah. After last year, after I returned from CPP now, I got idea we need something similar here, some smaller, obviously. And there is no user group in Prague, in Czech Republic, so I decided to start one. And I asked our CTO of Avast to support, and he decided he will support me. So I'm sponsored by my employer, and I'm able to attract great speakers. I had Matt Gottbold and Tony van Aert in the last one, and next will be in January, and I will have Guy Davidson and 2 local speakers. And I think I can announce July guest. It will be Eric Niebler and Bryce Lalbach.
So I thought that the Denver group had it good.
And we are trying to stream all our talks publicly. So we try to give back to community worldwide.
Yeah. So you say stream as in do them live or just put them up afterwards?
Live.
Oh, wow. Wow. Yeah. Wow.
People can feel like being there, and they can ask questions, and it's actually easier on my part. I don't need to cut the video, and everything is online straight away.
But we have a live endorsement from Matt Godbolt in the chat saying that it's super cool and fun to talk at Hana's user group. So anyone else has a chance.
Yeah, Matt was a great speaker.
Yeah, and we loved having him as a guest, and loved having him at CPPCon. So tell us about your CPPCon experience.
My CPPCon experience was great. It was my second time this year, and I hope I will be there next time. It's sometimes overwhelming, so many people there, and I was so tired every day, but I woke up early and again enjoy the conference, and then I fall asleep for like 2 days afterward. And it's so much content, you always miss something.
Well, that's by design. I mean, there's never a time when we say, oh, we can't do that. People wouldn't be able to go to all the things.
Actually, this year, sometimes I enjoy more discussing with people outside the talks. So I spent less time on talks than last year, but I think this year was even better for me and for a lot of people.
I think this is not an uncommon experience. It's a little bit surprising to people who first go to conferences that the real value of the conference is not the sessions. And at first, everybody thinks that's what I'm going is to see these sessions. Well, you're going to session about that. And seeing them live is better than seeing them recorded because you can ask questions and because you actually have a different experience. Also, seeing them live is better because you get to see so many, because nobody would actually go, say, I'm going to watch, 20 YouTube videos over the next week, right? You just wouldn't do that. And so you'll be able to see much more content than you could online, even though it is available online, but nobody does that. But the real value, as you say, is talking to people is that experience. And there's no substitute for that. And which is why people who come to the conference come back, despite the fact that all the content's free. No, there's a reason to come to the conference.
I think the best thing for my first year on CppCon for me was meeting people I know from internet. They are existing, they are famous, and I can talk with them, and they are just ordinary humans as me. It was the best experience I had.
Yeah, I think that people are approachable. I mean, it's very, I just love this community because people are approachable. As you say, somebody's famous, has done something pretty cool, like you have done, this really cool, innovative library, really nice. And yet someone can just come up and talk to you. And I think that I had somebody make the comment about CppCon that it's both overwhelming and not overwhelming. And I think what they were trying to say is, the content comes at you. You can't possibly do everything. But at the same time, you don't feel like you're personally intimidated by what's going on because you can just jump in and participate. Did you feel that way?
First few hours on my first CppCon, it was hard to approach someone, but few of my coworkers just threw me into crowd and it was fun. And this year I did the same for them. They was afraid to ask or talk to someone, so I just introduced them. Have you met Andre? No. Then they started talking. And then they talked for an hour, maybe 2, and it was fun.
So two years ago, did you think you'd be saying that I just introduced someone to Andre?
Yeah. It's different now. Definitely different.
And last week, John, weren't you saying that some people were at least talking about having I went to see Hannah's talk live T-shirts done?
Right.
I think we should make this T-shirt. There will be a last chance to watch my talk live on CPP on C. So be there.
You watched? Econ video yet?
Sorry,
I think I missed something there.
I just said, have you watched the CppCon video yet? I have difficulty watching myself. I tend to not watch them.
I never watch myself. I prefer to not watch myself.
I do sometimes just to see if I can focus on something I can do better next time. So it can be hard, but
I prefer someone telling me what should I do better, not watching myself, because no way.
Have you thought about taking the conference training, the CppCon training on how to give presentations? Were you there? Did you take that one this year?
I was there, and I greatly enjoyed it.
You did take it?
Yeah, it was really fun, and I think everyone who is willing to talk in future should take similar training, because it was really helpful. And get training from Kate or Scott was awesome.
And Andre as well.
Andre.
Yeah, I did that too. It was definitely very worthwhile and very entertaining.
And it was, as I told people, literally a once-in-a-lifetime opportunity. I think we're going to offer a class again, but I'm not sure we're going to be able to get the same lineup of instructors. I'm sure whoever we get will be great, but that was an amazing an amazing lineup of instructors. So I'm glad you got to take that class, and I hope it did it give you more confidence as you were speaking?
Yeah, it helped. I got feedback from Scott afterward, and I felt better about my talk, because I showed pieces of my talk during the training, and it was helpful. I think all first-time speakers should go there.
Not even just first-time speakers.
Yeah, but all first-time speakers should be there.
Right.
And
speaking of upcoming talks, we didn't do the news, did we? I'm sorry. I guess I probably jumped over that, didn't I?
You did.
So the announcement from C++ Now is that the call for submissions is up, and the deadline is not very far away. So if you're thinking about coming to C++ Now as a speaker, check out the website, read all the information about what we're looking for, and make your submission. And you need to make it really within the next month. The deadline is in January, so it's coming right up. But C++ Now is learn an awful lot by giving.
I want to go.
C++. Sorry, you go.
Okay, I want to go there, but I need to find proper topic. I don't want to talk about regular expressions again and again.
What you can do is not talk so much about the library, but about some of the techniques that you tried. I mean, if you did something 7 different ways, you've tried a lot of techniques, and a tutorial on, moving things to compile time would be a great topic.
I'll definitely go to that talk.
Okay, I will try to submit it.
I think Phil and I wouldn't be the only ones in the audience. Were you going to say something about C++ on C?
I was actually going to say something about C++ Now first.
Oh.
Which is that it's C++ Now is the first C++ conference in Colorado.
It seems to be getting trendy, doesn't it? Everybody wants to have their conference.
So yeah, I definitely recommend going to or speaking at C++ Now if you can. But yeah, you mentioned C++ on C. Of course, my conference in the UK coming up quite soon now in February. I think we mentioned last week that the call for volunteers and students were open. That's still running. Volunteers will need to get their submissions in by the end of the month, I think it was. But we've now just launched a diversity tickets scheme as well. That's being run by the Hash Include C++ group. So I'm going to be providing free tickets, and they are running a GoFundMe campaign to try and sponsor the travel and accommodation expenses. And that was a great success at CPP.Con this year, so we're hoping to try and repeat that for C++ on C. So I'll get some links for that in the show notes. That's C++ on C.
I was delighted to see that, and great to see, and I'm glad that Include is doing it. Hannah, talk a little bit about what we did at CPP.Con, more than a little bit your responsibility.
We're really losing you, John.
Yeah.
Do you want to ask that last bit again?
Yeah, if you can hear me, I was going to ask Hannah to talk a little bit about the program that you just talked about at C at CPP. Hannah, that started that program for us.
It was idea of my coworker, and I just related to you, and then it started, and it's bigger. It was bigger than I expected. I didn't expect we'll send 5 women there, and it was awesome. I met all of them, and we should do it again.
We are doing it again.
Definitely, for every conference.
Mm-hmm.
There's no reason why not.
Great.
So we're definitely doing that for C++ and C.
Well, the limiting factor is will the community step up to support that? We're software engineering. We tend to be well compensated for what we do, and we should be in a position.
Unfortunately, we lost you completely now, John. Yep, we've lost him. So while we wait for John to come back, the other piece of news we were going to look at, well, I just wanted to briefly mention, just completely self-interest, of course, my role at JetBrains. ReSharper C++ has a release next week. In fact, the whole of ReSharper, particularly ReSharper C++ for this audience, the 2018.3 release. It's going to be quite a big release. Lots of little new features that really add up to a much greater experience. So if you use ReSharper C++, or if you don't, I'd encourage you to check that out when that drops next week. Looks like John has rejoined. Are you back with us, John?
No.
Maybe not. Okay. Then I think we maybe get back to the topic. There were actually a couple of questions from the chat that we didn't get to about the compile time regular expressions. If we can revisit that. Somebody was asking, apparently on YouTube, and Matt reposted it, can the generated code use compiler, SIMD, and text processing intrinsics, if appropriate, to take advantage of some of the cooler things modern CPUs can do?
I think compiler can generate special optimization for my cases. I didn't try to force it to generate such code, but I noticed that there are some SIMD operations in generated code, depending on compiler. In my case, GCC is generating better code than Clang, unfortunately.
Right, so you're relying on the compiler doing that for you, not doing anything special.
Yeah, it's exactly just it's just C++ code, nothing else.
Right.
My first iteration of library was trying to generate code with LLVM library, but I failed miserably. So I just did what I understand, which is such as C++ code, nothing else. So it depends on compiler.
Yeah.
So the compiler should be able to, any optimization tricks that it has at its disposal, it should be able to do those at compile time just as well as for generated code, right?
Yeah, you just need to give him some hints that this can be vectorized and this cannot, and compiler should do it, but not in. It's not doing in every case, unfortunately.
Matt is saying that there are some nice intrinsics that are available to the compiler. Compare all 8 of these characters at once to see the first one matching A through Z.
I never know about the intrinsic.
So maybe I need to talk to Matt offline. See if you can do version 8.
Yeah, you haven't done enough versions yet.
Okay, I will try.
So there was another question as well from the chat, from the other Matt, in fact. Have you been optimizing the time to build performance? So I presume the actual how long it takes to do the compile time part.
Yeah, I optimized it a little. Odin Holmes gave me a great hint about trampolining, technique called trampolining, which allows me not just optimize build time, it also allows me to parse arbitrary length of string, not limited by template recursion depth limit. Right. And it's a little quicker, but I don't see compile time as an issue for my library. If you have only one regex in your translation unit, which is completely normal use case for someone, it's you cannot even notice there is some compilation of your regular expression because it's so quick.
As long as you apply some common sense tactics, like not putting those regexes in the header file that you include everywhere?
That's just a little slower, but I did measurement for ordinary lengths, regular expression, like around 20 chars is cost of compiling regular expression is 150 milliseconds per translation unit. But if you use same regular expression multiple times in same translation unit in multiple function, it costs you virtually nothing.
Right. Not bad. Not bad. Okay.
Yeah. Sweet.
So welcome back, John.
Yeah, and I thought when I first connected, it was like, oh, this is great, and then it started to degrade a little bit. So I don't know what's going on, but
you do seem a bit more stable, and your signal's a bit more stable as well.
Thank you, I appreciate that. So I don't know how much. What I may have missed is what we were talking about the program that started on and with communities, and I think that's what I was talking about when I dropped out. I'm just saying that we should be able to.
I'm afraid we're losing you again.
Software engineers tend to be welcome.
Sorry, John, we are losing you.
Probably as soon as I start talking about money. Right?
Are you still there? No.
Yeah, I'm seeing you fine. I'm hearing you fine. Oh,
you're coming through in bursts. Maybe you need to just reconnect every few seconds.
I'm bursting. Oh, great.
Well, this will make an interesting Audacity recording anyway. So Matt says, I think John is trying to say we should crowdfund a modem. No, okay. In that case, while we wait for John to get his act together, Hannah, you're talking about your user group. Did you tell us everything that you wanted to tell us about that?
I want to invite everyone who is near Prague to join us. It's always better if you are there in person, not watching stream. But if you cannot be there, you can watch stream or recording.
Yeah.
But I always try to bring some famous guest and someone local to have nice presentation there.
Mm-hmm.
And also I'm trying to research different formats. I will go with lightning talks next time, inviting local speakers. John recently pointed me at one local speaker from National Center of Supercomputing, and he is going to talk on the meetup in next month. And thank you, John, for it.
Glad to do it.
And you're able to get all these big names because the meetup is sponsored by Avast.
Yeah, right? Meetup is sponsored by Avast, but I found people are very willing to go to Prague because everyone is loving Prague. And also we can cover your expenses, everything. So you just go to airplane and visit us, and you can be in Prague for 1 week or something, and it's fun for everyone.
And also bear that in mind.
And also it helps that the talks are public and not internal for company.
Yeah. Everything
is public for people.
And Matt Godbolt on the chat says, and also Hannah asks really nicely. Sure, that's a big factor.
Yeah.
This is what I learned in preparing the. Can you guys hear me?
Yes.
Yeah.
This is what I learned in preparing the call for submissions for C++ Now, because we ask the submitters what country they're from, and the Czech Republic has changed its name. Right?
Yeah.
The English.
Yeah.
English name is now, can you say it?
It's Czechia.
Czechia.
Yeah, or Czechy.
All right. Czechy.
It's a second official name, but our official name is still Czech Republic. We have like you can say France and longer name of France. I don't know what it is, but
I think it's called the French Republic. I think it is called the French Republic.
Yeah. So it's same. People talking that we don't have any short name usable officially. So our parliament vote this name, and it's officially recognized now.
Well, I had to update the submission system to change the name.
You don't need that. Both names are still official.
Okay, good to know. All right. So, what about your upcoming? Do you have talks that you're planning to do?
I don't have a specific topic yet. I researching one idea, and it's combining stud embed, if you heard about it, and compile time parsing to create protobufs in compile time without preprocessor. You will just include protobuf file, and it will create everything you need. But I don't know if it's possible or not. But with a combination of different things, especially stud embed, we like stud embed and we want it. If someone from committee is listening, please give us stud embed.
Well, tell us what stud embed is.
A stud embed is a constexpr function which should give you content of view to content of file you ask for. So if you have a file as part of your source tree, you can ask for content of shader. If you are doing 3D graphics, you can ask for JSON configuration file. You can ask for C code and transpile it to C++ with compile time machinery.
So essentially, it's merging the file into the application so that you can access it.
It gives you
runtime directly.
It gives you only content of file as a variable for constexpr or consteval functions.
Oh, I see.
And you can transform it into whatever you want and then store it. So original file is not stored in your binary. It shouldn't store.
Right.
So it's not the same as hash include.
At compile time.
Yeah, currently it's done in some cases with hash include and preprocessed file, which contains compile time variable containing data, all data you need.
Right. Here is that you're actually at compile time going to parse the file that you have runtime, and so you can parse the file. So the only limitation is that the file has to be fixed content. Right? It obviously is. It's time evaluation, so it has to be known in advance the format.
Yeah, it must be known during compilation, and there is a discussion if name must be fixed, static, if you want, in code, or dynamically computed. If the name is dynamically computed, I can recursively parse protobufs and then parse include protobufs and whatever I want. And I think it's a really useful use case.
Yeah, I can see that. There's a lot of programs. I know a lot of game programs load resources, essentially what we're saying. Some kind of data that is available to application. And sometimes there's a how you store the data to make it able to be how you want it to be and how we can solve that problem by having at compile time.
Afraid we're losing you again, John.
But then at compile time, it gets committed for the program.
I didn't hear you, John, but but I think it's create completely new class of problems and solution for them. For example, I had a lightning talk on a meeting C++, and I can see you can actually create transpiler of Python into C++ in future with this. So you can compile any language you want into C++. I think it's a little interesting feature.
I hadn't really thought about it this way before, but this actually sounds more and more like a feature that F# has called type providers. And when people first hear about type providers, they go, "Whoa, you can do that." The one thing you can do with type providers that maybe you can't do here is actually download stuff over the internet as part of the compile step.
Not yet.
But maybe we're not far off that as well.
I think standard doesn't specify what's the file and when the file you can take it.
Right.
So maybe if you use internet URL, depends on your implementation in future.
Exactly. Yeah. Now you got me thinking.
That sounds dangerous.
Yes.
It's definitely safe, and you should use it. And don't check anything. Don't check your input. Never check your input.
I think we've triggered Matt Godbolt on the chat. Please, no URLs, he says.
Matt has pointed a couple of other questions, but I'm not sure how seriously those are. How do you feel about having a Boost library named after you, Hannah?
First time I heard about the library was last year on CPPCon, and I was surprised. I don't know all libraries on internet, and I didn't use Boost 2 years ago. I'm using it now, and it was like it was funny. And then on Rapperswil meeting, on plenary session, I was sitting in second row, and Herb Sutter was sitting in first row, and he looked at me and he told me, "Oh, you are reason why you name your library Hana, but I need to correct it publicly. It's not named after me. It's coincidence."
I was quite pleased that they named Stud Phil after me.
Obviously.
There you go.
Obviously.
Yeah. So do you actually use Boost, Hannah?
No, I just look at it. I read documentation, and I didn't use it in some my library or code, not yet, but I'm going to. I will try it. But for now, I somehow prefer to write my metaprogramming code by myself, because reading metaprogramming code, it's really hard, and I prefer to know what's going on, especially doing regular expression or stuff. When I don't know if at the beginning I wasn't sure if it's possible to create regular expressions in compile time, so that wasn't time to use any other library.
Well, it makes sense. Most metaprogrammers use Hana, but you are Hana, so
yeah, it's becoming de facto standard library for metaprogramming now.
Exactly.
So
you just need to drive the state of the art.
I was going to say, I don't know if most people.
Oh, I think that finished John off again.
I'm not sure most people are using a place to start.
Sorry, John, you've completely gone. I'm going to assume that whatever it was you were asking wasn't that interesting, so that we can just move on.
Yeah.
And if you disagree, you have to come back. So you were talking about your next idea being to do with Stood in Bed, and we looked into that, but it sounded like we did have an idea for your next talk earlier. So that could be something else you'll be working on next, maybe. The different iterations of your regular expressions library. And behind each one.
I make several iterations of my library, to like 4 or 5 last year, and I got experience with different techniques. And in last iteration, I found that the best technique for my use case is function overloading. And one idea you gave me earlier was to make talk about comparing these techniques and these pluses and minuses. It's interesting, but I would need to remember what was the positive sides of different techniques, and I don't remember everything. I'm not sure if I will be able to make the talk from it. I will try, but it's my backup plan. I should present the protobufs. It's more interesting for me.
Okay. So, John, are you back?
Yes, I hope so. Is protobuf something that you're using, or is this just got you intellectually curious?
The protobufs, you mean?
Yes.
Yeah, we are using protobufs in a lot of our internal code, especially on backends. So I always hating modifying my pipeline just because I need to use protobufs to create to generate files. So I'm looking to solution how to avoid the need of having the preprocessor for my pipeline. That's all.
And how would that be better than a code generation step? Or would it be?
For example, if you have a header-only library, you will not need to introduce code generation step. Just include your header-only library, and you can just use it with your protobufs, in theory.
Would there be any implications for debugging in that case?
It will be same as with any other template code. There will be structures and classes you don't know, but they are generated in your library. I think it's same as debugging std stat library vector or something like map. You shouldn't look inside.
Right. Sometimes you do have to, though, which is why I thought of it, because that is sometimes a problem when you have too much stuff generated at compile time. You do need to look into the guts of it, and sometimes you do. That could be a problem.
I invent special technique to debugging metaprogramming code with my regular expression, and it's meditating.
Right. Okay.
Just sitting and thinking where is the error. But during when I was writing the library, whenever I introduce new feature, I always write a lot of tests. In this case, static asserts.
Right.
So it's relatively easy to make new features without breaking anything else if you have tests. So please write tests.
Absolutely. So it's a more thoughtful approach to programming.
I actually try to write most of my tests as static assert because it's straightforward. It's easy, and if you have everything context per, it can be done.
Right.
So maybe you should name a catch to static catch in future.
Well, the question has been raised. In fact, just recently a feature's got into catch 2, not written by me, but to do not type-driven tests, but type parameterized tests. So you can write one test against many different types. The tests still execute at runtime, but they are effectively generated for each instance of the type.
That's really interesting.
So good luck trying to get Phil to change the name of the library. I've been trying to get him to change it to Boost Catch for a long time, and I haven't had any success with that.
Nope. Well, there is a boost test.
Huh.
Yes, but there's no boost catch.
No. Well, you'll have to keep boost trying.
Or boost give up.
Well, that, yeah.
I missed that. I'm not you just said.
When I come to edit this episode and I actually get the unadulterated file from Audacity, I'm going to have to manually put in all the points that John cuts out so we can recreate the experience.
Yeah, good luck with editing this. I'm feeling for you, Phil.
I'm sure you are.
All right. Well, now suddenly I have good connection. I wanted to ask Hana about the same question I asked about protobuffers, which was about regular expressions. Are you using those in your work? Why did you decide to take that on?
I started to be interested in regular expression a long time ago when I was studying on a university formal languages, and I think it's a really nice concept, and it's clean and it's beautiful. And I tried to implement regular expression on my own as runtime code, and then I tried again. So it's like my hobby of mine. But also in my work, in my source code, I inherit from my previous coworker. There was several hundreds of regular expressions, and it was like, that's crazy. And my first thought was change this regular expression into state machines, but they are hard to write and hard to debug for people who don't know state machines. So I was searching for a way how to make them quicker, easier debuggable, and that's all. That's the reason I started working on compile-time regular expressions. If you make a syntax error in compile-time regular expression, it will give you hard compile-time error. So that's also positive thing about the library.
Yeah, that's very nice. And
So
has there been talk of, this is something else now, but maybe you know more about this, because I think there's been talk of adopting the FMT library into the standard or something like it. And doesn't that give you the opportunity to specify types of insertion points in a formatting string and have them checked at compile time?
I think, yeah, I think author of formatter library is using some sort of checking of types, but I didn't yet saw the code. Okay. I suppose there are some checks. I heard about them, but I'm not sure. But I think he can use same technique as I'm doing to check.
That's what I'm thinking. Yeah, yeah.
Because you can, from the pattern, you can generate tuple, and you can check the tuple against arguments. Mm-hmm. I think it should be relatively easy. So a part of my library is just syntax parser you can use for this type of utilities. So you don't need to look on a regular expression. All the stuff is different part of library. You can just take the parser and build type from your string.
So you actually, your library is a composition of several smaller libraries you can use independently. That's useful to know.
Mm-hmm. So you can just design your grammar and create a function which will give you tuple of types based on your pattern, for example.
Right. Are there any other useful parts of the library that you can use independently?
Only this one.
Okay. Well, that's a good start.
Yeah, you can use my type list, and my type list is like 20 lines long code, only one-liners. It's small. It can fit in one slide. It's awesome.
Right. How does that differ from just a plain variadic template pack?
I have operation like push, pop, and it behaves like a stack and like a queue if you want.
Right. Right. No, it does sound useful then. Should definitely have to have a look at that.
You should.
So, John, do you? Are you still there? First of all.
Well, I'm here. I'm busy because I'm not sure if you can hear me.
We can now.
Yeah.
So while we can hear you, do you have anything else to add or to ask?
Well, I was going to ask something about metaprogramming in general, in the sense of you've been doing that quite a bit now. how do you feel that that's different from more traditional approach that C++ users? There's not very many people who are doing metaprogramming, but the ones that are tend to get really wrapped up in it. And I was going to ask you about the experience of that.
My experience is it's really hard. And if you try to program in same style as you are used to for ordinary programs, you are screwed. But if you try to think functionally, it's suddenly some beauty emerge, and it's really simple. I tried to write my type list as a class with a member function, and it was really hard. Then I decided to move my function as a free function, use them, and suddenly the code is really, really small, and you cannot make error with it because there is no space for error. So you just need to think differently than you are used to.
So I hope that I don't get cut out on this, because this is a great story, and it's about Andre with his loci library. There were people who asked him to submit that to Boost, and when he started looking at that, one of the things that the Boost guidelines are is that if you have some functionality that Boost has a library for, you should use the Boost version rather than. And so he was going to look at having to re-implement loci using the template metaprogramming library, the Boost template metaprogramming library. The Boost template metaprogramming library was designed with the idea that C++ programmers would understand what STL containers look like. And so it tries to have an STL container kind of interface. And Andre was just aghast. He said, no. It's just the nature of what you're doing. It's a functional problem, and you want to use functional style programming. And trying to fit an STL API over type lists is just crazy. And so he pushed back at that. And loci never went into Boost, but I thought he made a very important point that the natural way to do template metaprogramming is to think functionally. And so I actually had a friend who was a C++ programmer, but he took a job using where he was going to use something called Scala, which is a functional programming language built on top of the Java virtual machine. And what I told him was, I said, I don't know how successful you're going to be or how much you're going to enjoy this new company or whatever, but I said, if you learn Scala, you will probably be a better C++ programmer afterwards for having learned Scala, because understanding how to program and think functionally is something that I think C++ programmers need to do more of. For two, it makes better template metaprogrammer. It also makes you a better programmer if you're doing anything you want to think of from the point of view of really. And I think that C++ that we can learn from the functional.
John, we probably lost you again.
Did you hear any of that?
we were losing you at the end there. I'm not quite sure what your conclusion was. No.
I think
conclusion. Can you hear me?
Oh, yeah, you're back. The beast is back. Or maybe not.
Say that I C++ to learn from.
Sorry, John.
But also
not getting it. Maybe you can type it. The one bit that I did get from that, and I did pick up on, was when you were talking about treating type lists as STL containers, and you said that Andre pushed back on that, and I thought that was quite appropriate.
Yeah, I think functional programming is future, at least partially, even for C++. It's easier testable, and it's usually even safer. And if you do runtime function programming, you can do compile time programming straight away without any problems.
You won't get any pushback from me on that.
what I was hoping I was going to be able to say is that I think that C++ programmers can learn from the functional programming discipline in two very important areas. One is in template metaprogramming or metaprogramming, but the other is in the area of anything having to do with multi-threading, writing your code so that it has minimized, so it minimizes its side effects, and thinking in a functional way. I don't think all programs or all problems are easily solved that way, but the ones that are, you have lots of benefits about reasoning about code if you've written it in a functional style. I hope it actually makes it to the to the podcast.
I totally agree, and it's harder to write functional some problems, but I think it's not about objective hardness of writing code. It's about what we are used to write. And if we learn something new, then we can. I think it's about willingness to learn new things. Nothing else.
I agree. And see my talk, Functional C++ for Fun and Profit, for details. Okay, well, I think we're out of time. Sorry, Hannah, for some of the connection problems we've been having. I'll try and clean it up as much as possible in the editing. I think it's time for us to say goodbye, unless you have any final words you want to say.
Come to my talk on CPP on C.
You heard it here first, or maybe second.
Okay.
Thank you for that.
And thank you very much for joining us.
Thank you. So, shall we say safe coding?
Yeah, safe coding.
To everyone, safe coding.
Safe coding.